Hello students, I will be discussing about fusion future, that is 7.09 from physics higher tier. Hydrogen, fuel for the stars. Okay, hydrogen is the lightest element but most plentiful. 75% of the sun is hydrogen. Okay, that sun contains 75% of the hydrogen. There is also lots of hydrogen on earth, though most has combined with oxygen to form water. These are the atoms, that is hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 2 is known as deuterium and hydrogen 3 is known as tritium. These are the isotopes of hydrogen that have the same atomic number but different mass number, as you know. The stars are powered by nuclear reactions. Most use hydrogen as their nuclear fuel. So hydrogen is acting as a nuclear fuel in the stars. One day it may be also the fuel for the reactors on Earth. So hydrogen can also be used as fuel on the nuclear reactor for the Earth. Okay. Energy from the nuclear changes, that how the energy comes, that the energy we get from nuclear changes. The protons and the neutrons in the nucleus of an atom are held tightly together by a force called a simply strong nuclear force. That is the central part of the atom and the nucleus. There is protons and neutrons which are held by strong nuclear force. However, in some nuclei, they are more tightly held than others. To get energy out of the nucleus, the trick is to make the protons and neutrons regroup into more tightly held arrangements than before. They are needed to be regrouped, that means into more tightly held arrangements than before. You need to regroup them in order to make the arrangement more stronger, more tightly. Protons and neutrons in middleweight nuclei tend to be most tightly held. Okay, the protons and neutrons in middleweight, not high or not low, that is in the middleweight nuclei, tend to be most tightly held. So joining very light nuclei together can release energy, as can splitting up very heavy ones. So you need to take protons and neutrons of the middleweight, not very light or not very heavy. The two processes, fusion and fission, are shown in the right. As you all know that fusion is the joining up of the nuclei to form heavier ones and fission is the splitting up to form the lighter ones. These are the diagrams of the two processes. So fusion is difficult to achieve because the nuclei are charged and repel each other. Okay, to beat the repulsion and join up, they must be travel very fast for the above reaction. This means heating the hydrogen at least 40 million degrees Celsius. That is a huge temperature. Okay, so this is difficult to achieve, that is to join. Okay, and fission is used in the reactors in the nuclear power station. Technically it is much easier to achieve than fusion, because neutrons are not repelled by nuclei. The core temperature in the nuclear reactor is only a few hundred degrees Celsius. That means unlike fusion, in fission you need a small amount of energy compared to fusion, because 40 million degrees Celsius and few hundred degrees Celsius, you can compare the ratio. That is a very small proportion during fission reaction. Okay, so it is easier to achieve than fusion. Now, building of a fusion reactor, because there are some difficulty in building up the fusion reactor, that is immense temperature is needed, as you have seen that fusion reaction that needs. So fusion reactor also needs immense problem, that is immense, that is huge temperature is needed. That is hydrogen must be heated to at least 40 million degrees Celsius and kept hot and compressed, otherwise fusion stops. No orderly container can hold the super hot gas like this. So scientists are developing reactors that trap the reacting nuclei in a magnetic field. So scientists are taking measures to find an alternative route to control these super hot gases, but it has advantage. As you have seen, the fusion reactors will have huge advantage over today's fission reactors. That is how They will produce more energy per kilogram of fuel. Their hydrogen fuel can be extracted from seawater. Their main waste product, helium, is not radioactive, and they have built-in safety. If the system fails, fusion stops. That means fusion reactors will have a huge advantage, that is it will produce more energy per kilogram of fuel. The hydrogen fuel extracted from the seawater, their main waste is a helium. Helium is not that much of a radioactive substance. This is not that much harmful, and if there is any problem, they are built in such safety that if there is any problem or any faults is detected, the fusion stops at that immediate point. Okay. Now the fusion in the sun, that is how sun gets its energy. Like most other stars, sun gets its energy from the fusion of hydrogen into helium. Okay, that means hydrogen fused to form helium. Deep in its core, the heat output and huge gravitational pull keep the hydrogen hot enough and compressed enough to maintain fusion. Okay, so far the sun has used up less than half of its hydrogen. It has enough left to keep it shining for another 6 billion years, such a huge time. In the sun, fusion happens at only 15 million degrees Celsius. That means in sun it happens in a less amount of time, less amount of temperature, that is 15 million degrees Celsius. But sun uses different fusion reaction from those being tried on Earth. Okay, so sun uses different types of fusion reaction. That is, if the sun were scaled down to the size of the nuclear reactor, its power output would be too low to be useful. So if we scale the sun with size of the nuclear reactor, the power output would be too low to be useful. Okay, so this is the lecture on the fusion future. That is, the scientists are developing new thoughts on fusion reactor, how to use how to make it more useful using less amount of heat, because 40 million degrees Celsius is not a very easy task. So they are developing new way to take advantage of the fusion reactor. I hope you are clear with the lecture. If there are any problem considering this topic, please let me know on the comment section. I hope you are clear with the video. Stay safe.